Hi, today we're doing an overview of our systemsarchitect.io section on 14 AWS CloudWatch strategies. AWS CloudWatch quietly decides whether your team catches a problem in seconds or discovers it from an angry customer. The difference between a monitoring setup that just collects data and one that actually protects your systems comes down to how deliberately you configure it. This walks through 14 strategies for using CloudWatch to build monitoring, alerting, and observability that scales with your infrastructure and keeps your team ahead of incidents rather than reacting to them. 14 AWS CloudWatch strategies. 1. Implement detailed metric collection. 2. Set up multi-tier alerting thresholds. 3. Use composite alarms for complex scenarios. 4. Implement log aggregation strategy. 5. Create custom metrics for business KPIs. 6. Configure cross-account monitoring. 7. Use metric math for advanced analysis. 8. Implement automated response actions. 9. Set up log insights queries. 10. Define dashboard strategy. 11. Implement metric stream processing. 12. Configure synthetic monitoring. 13. Optimize log retention and archival. 14. Implement container monitoring. 1. Implement detailed metric collection. Standard CloudWatch metrics arrive at 5-minute intervals by default, which is often too coarse to catch fast-moving problems before they escalate. Why collect metrics every minute? Detailed monitoring collects metrics at 1-minute intervals instead, giving you a much sharper picture of how your resources behave under load, though it does add cost per metric. This granularity matters most for services with tight performance requirements, like databases and auto-scaling groups that need to react quickly to demand spikes. A practical approach is to reserve detailed monitoring for production-critical resources and lean on standard monitoring elsewhere. 2. Set up multi-tier alerting thresholds. Multi-tier alerting separates the noise from the signal by assigning severity levels like info, warning, and critical to your CloudWatch alarms based on how urgently they need a response. Without this structure, every alarm looks equally important, and teams quickly learn to ignore notifications altogether. Setting distinct thresholds for each tier lets you catch degrading trends before they become outages. A good starting point is to map each alarm to a specific runbook, so responders always know what a given severity level requires. 3. Use composite alarms for complex scenarios. What do composite alarms actually do? A single metric crossing a threshold rarely tells the whole story, and composite alarms let you combine multiple underlying alarms with and or logic to reflect that reality. Instead of paging on every spike in CPU or latency, you can require several conditions to align before an alert fires, which dramatically cuts down on false positives. Composite alarms are especially useful for multi-tier applications, where a real incident usually shows up as a pattern across several services. Once in place, they tend to produce fewer but far more trustworthy alerts. 4. Implement log aggregation strategy. Logs scattered across dozens of services and accounts are nearly impossible to correlate when you're diagnosing an incident under time pressure. A log aggregation strategy centralizes output from EC2 instances, Lambda functions, containers, and managed services into CloudWatch logs using consistent, well-organized log groups. Centralized logging enables correlation across services, so you can trace a single request as it moves through a distributed system. A practical tip is to standardize log formats, ideally structured JAI, so CloudWatch logs insights queries can parse fields consistently. We have a lot more about this on systemsarchitect.io. See the full section there. Also make sure to like the video and subscribe to the channel for more and check the video notes for links. 5. Create custom metrics for business KPIs. Infrastructure metrics like CPU utilization tell you how your systems are performing, but they don't tell you whether the business is actually succeeding. Custom metrics let you publish application specific and business relevant data points, such as completed checkouts or failed logins, directly into CloudWatch. These metrics bridge the gap between technical health and business impact, making it possible to alert on what actually matters to stakeholders. Defining custom metrics well requires collaboration with product teams to identify which numbers genuinely indicate success. 6 point, configure cross account monitoring. Organizations running multiple AWS accounts for security or billing isolation often end up with monitoring data scattered just as widely. Cross account observability in CloudWatch lets you designate a monitoring account that can view metrics, logs, and traces from linked source accounts without duplicating data. This is especially valuable in organizations using AWS organizations, where different teams each operate in their own account boundary. The result is a single, unified view of your entire multi account infrastructure. 7. Use metric math for advanced analysis. Raw metrics are useful, but the questions you actually want answered often require combining or transforming them, and metric math makes that possible directly within CloudWatch. You can use it to calculate ratios like error rate as a percentage of total requests, or combine metrics from different sources into a single derived value. Metric math expressions can be saved and reused in dashboards and alarms, so once you've built a useful calculation, you don't have to recreate it. It's particularly powerful for surfacing trends that aren't visible in any single metric. 8. Implement automated response actions. Manual incident response introduces delay at exactly the moment when speed matters most, and CloudWatch alarms can trigger automated actions through EventBridge and Lambda to close that gap. Common responses include restarting unhealthy instances, scaling resources, or rolling back a deployment when error rates spike. Starting with low risk, well understood remediation actions is a safer path than automating complex multi step recovery from day one. It's important to log every automated action taken so your team maintains full visibility into what the system did on its own. 9. Set up Log Insights queries. CloudWatch Logs Insights lets you run fast, purpose-built queries against your log data, but writing one from scratch during an active incident wastes valuable time. Why save your queries? Saving frequently used queries for common troubleshooting scenarios, such as finding all 5XX errors in the last hour, means responders can pull up relevant data in seconds. Well organized saved queries effectively function as a shared troubleshooting playbook. It helps to name and tag saved queries clearly by the scenario they address, so they're easy to find under pressure. 10. Define dashboard strategy. A single dashboard trying to serve every audience usually ends up serving none of them well, which is why a deliberate dashboard strategy matters. Engineers troubleshooting an incident need deep, technical, real-time detail, while leadership needs a high-level summary of overall system health. Purpose-built CloudWatch dashboards organized by team or use case let each audience see exactly the metrics relevant to their role. Regularly pruning outdated widgets keeps dashboards genuinely useful rather than becoming digital clutter. 11. Implement metric stream processing. CloudWatch metric streams let you continuously stream metric data out to external analytics platforms in near real time without polling the CloudWatch API. This is particularly useful for organizations that have invested in specialized analytics tools, since it lets those tools receive AWS metrics as a live feed. Setting up a stream typically involves configuring a Kinesis data firehose delivery stream as the destination. It's worth monitoring the stream's own health since a silently failing stream can leave your external dashboards showing stale data. 12. Configure synthetic monitoring. CloudWatch Synthetics lets you run scripted canaries that simulate real user traffic against your endpoints and APIs from multiple geographic locations, catching problems before actual customers do. This is especially valuable for detecting regional outages, DNS issues, or certificate expirations that might not show up clearly in your internal metrics. Canaries can be scripted to test full user journeys, like completing a login flow rather than just checking a single endpoint. A practical tip is to alert on canary failures with the same urgency as real user facing alarms. 13. Optimize log retention and archival. Keeping every log line in CloudWatch logs indefinitely at full cost is rarely the right trade off, since most log data loses its operational value within days or weeks. How do you keep costs down? A tiered retention strategy sets shorter retention periods for data you need readily searchable while exporting older logs to S3 for cheaper long term storage. S3 lifecycle policies can further reduce costs by transitioning archived logs to Glacier as they age. Reviewing retention settings periodically prevents both unnecessary cost and compliance risk from logs being deleted too early. 14. Implement container monitoring. Containerized workloads introduce a layer of ephemeral, fast changing infrastructure that traditional host based monitoring wasn't designed to track well. CloudWatch Container Insights collects and aggregates metrics and logs from ECS, EKS, and Kuber NTE's environments, giving you visibility into both the containers and the underlying cluster. Container Insights also automatically creates dashboards summarizing cluster health, saving teams from building that visibility from scratch. Enabling it does add some cost, so it's worth weighing that against the value of the visibility gained. Taken together, these 14 strategies move CloudWatch from a passive data store into an active part of how you operate your AWS infrastructure. The goal isn't to implement every strategy at once, but to prioritize the ones that address your team's biggest visibility gaps first. As your infrastructure grows more complex, revisiting these practices regularly will keep your monitoring, alerting, and observability aligned with how your systems actually behave. Thanks for watching, and we'll see you in the next one. Thanks for checking this out. Hope you learned something. Find a lot more articles and guides on both systemsarchitect.io and codeguides.io.